Hello, my name is Francesca Tabor. I am here in New York and I am an AI consultant with Early Information Sciences. Today, we will be looking at how you can transform product data management for enhanced searchability and business growth using large language models, RAG, and our very special algorithm that we've developed. So let's take it away. So here is a case study of a multinational manufacturer and industrial supplier of electronic components and precision machine parts. This company, with an extensive product catalog comprising 7 million SKUs and 100,000 products, faced significant challenges in managing and optimizing their product data. We needed to update the product names using industry standard terminology. This was crucial for enhancing product findability and selection. To achieve this, we created an industry standard terminology dictionary of standard terms, ensuring consistency and ease of search. It was essential to ensure that the cleansed product names complied with established data quality standards. This included standards for length, capitalization as per the AP style book, formatting, and uniqueness requirements. Another critical task was to review and rewrite product descriptions as necessary. The goal was to ensure that the descriptions were unique, relevant in terms of form and function, and adhered to proper sentence structure. This step was key in improving the overall quality and usability of the product data. These steps were not just about updating data, but transforming it to meet the company's needs in a structured, compliant, and user-friendly manner. This transformation was aimed at achieving significant improvements in product findability, data quality, and overall customer satisfaction. Now, let's explore the solution highlights that demonstrate how we address the challenges faced by a client in the industrial manufacturing distribution sector. At Early Information Science, we apply a high degree of automation to meet each product data quality requirement. This reduces manual effort and ensures consistency across the board. Our approach incorporates organizational knowledge graph data and user behavior telemetry. With a retrieval augmented generation RAG framework, this ensures that we capture and utilize relevant data effectively. We leverage generative AI and large language models, LLMs, integrating them with client source data and industry references. This powerful combination enhances the accuracy and relevance of the product data. Our methodology delivers projects at scale through an efficient and repeatable framework. This ensures that we can consistently replicate success across different projects and clients. Throughout the project, we create customized assets specifically for the client. These assets, which include proprietary LLMs, embeddings, localized token stores, are made available during or at the conclusion of the project. Our solution is finely tuned for industrial manufacturing and distribution companies. It utilizes aggregated data sets and applicable reference standards to ensure the solution is relevant and effective. Despite the advanced technology, human curation remains central. Information architects and business analysts provide oversight to ensure quality and relevance. Their roles include injecting brand voice, emotional context, customer intelligence, validating business requirements and analyzing, onboarding, and normalizing input data sources, defining and iterating data rules and style guidelines, conducting quality assurance, and reviewing machine-generated outputs. These highlights showcase our comprehensive approach that blends advanced AI technologies with critical human insights, ensuring our solutions not only meet but exceed client expectations. To measure the success and impact of our solutions, we track a variety of metrics across different functional areas. Here are some of the key metrics we focus on. Top searches, including the most common searches, helps us understand what users are looking for to optimize search functionality. Search exit rate. This metric indicates how often users leave after performing a search, helping us identify issues in search results. Save searches, tracking save searches gives insights into what users find valuable enough to revisit. Next, we've got engagement and conversion. So average visit time measures how long users stay on the site, indicating their level of engagement. Pages per visit, the number of pages viewed per visit helps us understand user navigation patterns and content engagement. Conversion rate, the percentage of visitors who complete the desired action, such as making a purchase or filling out a form. Then we have content and data quality. Tagging fill rate ensures that content is properly tagged, which is crucial for searchability and organization. Never found rate measures how often users receive no results with their searches, highlights gaps in content. Content downloads tracks number of downloads, indicating usefulness and relevance of the content provided. Then we have new product launch. Product onboarding into e-commerce and ERP systems measures the efficiency of integrating new products into various systems. Time to campaign launch tracks how quickly new products are ready for marketing campaigns. New product support incidents monitors the number of support incidents related to new products, helping identify issues early. Customer service, time per incident measures the average time taken to resolve customer service incidents. First time call resolution tracks percentage of incidents resolved in the first call, indicating efficiency and effectiveness. Call deflection measures how often customers find solutions through self-service options, reducing the need for direct support. Then we have supply chain management. Time to onboard new suppliers measures the efficiency of adding new suppliers to the system. Supplier data quality ensures the accuracy and completeness of supplier information. On-time delivery rates tracks the punctuality of deliveries, a critical factor for supply chain effectiveness. To effectively measure and improve our e-commerce initiatives, we use a structured approach with scorecards that link business unit objectives to underlying processes and data. Let's walk through this framework. So a CEO might ask the question, how will this increase revenue? Well, let's start at the bottom. At the foundation level, data and content support processes. Here we measure aspects such as heuristics, applying rule of thumb and experience-based techniques to improve data usage, fill rates, ensure the data fields are adequately filled to support various functions, content quality, maintaining high standards of content to ensure user experience and searchability. Next, we have process scorecards. Moving down, we look at the business processes that enable these objectives. Key process indicators include leads, the number of new potential customers identified, conversion, the rate at which leads are converted into actual sales, site traffic, the volume of visitors to our e-commerce platform reflecting our reach and engagement, search relevance, ensuring that search results are relevant and helpful to users, therefore improving their experience and likelihood of purchase. And last but not least, we have the outcome. So at the top level, we focus on business unit objectives. These are directly tied to key business outcomes such as new business opportunities, tracking how well we're generating new leads, business avenues, average order size, monitoring the average value of orders to ensure we are maximizing revenue per transaction, and then total account revenue, measuring the overall revenue generated for accounts to gauge financial health growth. Now, the digital team's question will be, how do I know that the data, taxonomy, architecture, AI tool, knowledge, search is working? Well, for this, we look at product content, ensuring comprehensive and accurate product data, AI training data, utilizing high quality data to AI models effectively, CRM, leveraging customer relationship management systems maintain and use customer data efficiently. These scorecards provide a holistic view of how data, processes, and outcomes are interconnected, ensuring that every level of operation supports the overall business objectives and drives revenue growth. In this slide, we will compare the generation and retrieval approaches for handling user queries, emphasizing their respective strengths and limitations. User query processing. The process begins with a user query. The query is then processed using a large language model, LLM, to understand the user intent. Understanding the intent accurately is crucial for providing relevant and useful responses. Generation approach. Information source. This approach relies on publicly available information. The advantages can provide responses to a wide range of queries due to access to vast amounts of public data. The limitations is it's prone to hallucination. LLMs might generate incorrect or fabricated information. Exposure of IP. There's a risk of exposing intellectual property when generating responses from public data. Missing audit trail. It's difficult to trace origin responses, leading to challenges in verifying information accuracy. Now let's compare this with the retrieval approach. With the retrieval approach, the information source essentially uses proprietary information such as corporate knowledge bases and internal documents. The advantages are there's no exposure of IP. It keeps sensitive information within the company, reducing the risk of intellectual property exposure. Then we've got corporate knowledge, leverages company-specific knowledge, ensuring that responses are accurate and relevant to organization's context. Then we've got auditability, provides a clear audit trail, making it easier to trace, verify the information used in response. The limitations may be limited by the scope and depth of the internal data available. Response processing. Regardless of whether the information is generated or retrieved, the next step involves processing the response using an LLM to format it computation. This ensures that the response is not only accurate, but also easy for the user to understand and engage with. The final response. The processed response is then delivered back to the user, completing the query resolution process. By understanding the differences between the generation and retrieval approaches, organizations can choose the best method based on their specific needs, data availability, and risk considerations. So, retrieval augmented generation has evolved. In this slide, we illustrate the evolution of retrieval augmented generation frameworks. Let's take a closer look at 3 distinct stages: naive RAG, advanced RAG, and modular RAG. So, naive RAG. Process overview. Process begins with a user query, which, along with relevant documents, is indexed. Retrieval occurs directly from the indexed documents. The retrieval information is then used to prompt a frozen large language model. Finally, the LLM generates output based on the retrieved information. Key characteristics: simple and straightforward, limited by the lack of pre and post retrieval processing, which can impact the quality and relevance of the responses. Next, we've got advanced RAG. In this stage, the user query and documents are first indexed. Pre-retrieval enhancements. Techniques such as query routing, query rewriting, and query expansion are applied before retrieval to improve the relevance of results. Retrieval is performed from the enhanced index. Post-retrieval enhancements. Processes like re-ranking, summarization, and fusion of retrieved results are applied to further refine the information. The refined information is then used to prompt a frozen LLM, which generates the final output. Key characteristics: improved accuracy and relevance through additional processing steps, more sophisticated handling of queries and results. Next, we have modular RAG. This stage introduces a highly modular approach with various interconnected modules such as routing, directs the query to the appropriate processing path, search, retrieve, predict, pre-rank, read, memory, fusion. Each module performs specialized tasks to ensure the retrieval and generation process. Rewrite and demonstrate. Additional modules that can modify and present the information in the most useful format. The modular structure allows for flexible and dynamic processing tailored to specific needs and contexts. Key characteristics: highly flexible and customizable, capable of handling complex queries, providing highly relevant and accurate responses, enhanced auditability, and control over the information processing pipeline. By evolving from naive to advanced, and finally to modular RAG, we have significantly improved the ability to retrieve and generate high-quality, contextually relevant information. This evolution ensures that our systems meet the diverse and sophisticated needs of users while maintaining control and accuracy. In this slide, we will discuss our comprehensive data enrichment process. This process integrates multiple sources and types of data to enhance the quality and utility of information, ultimately improving user experience and business outcomes. Source data to be enriched. We start with 4 elements, such as original product name, original description, catalog context, attribute names, schema, MDM, PIM, ERP data. This foundational data is critical for providing context and initial structure. Related artifacts. Additional related artifacts are incorporated to enrich source data. Web pages, content, digital assets, images and diagrams, product sheets and manuals, existing search index, knowledge base, how your audience is segmented. These artifacts provide supplementary information that enhances the completeness and richness of the data. Rules and governance. Ensuring compliance and consistency is achieved through rules and governance. Standard bodies, ISO, TC, and SC. Restrictions, style guides, branding, examples, positives and negatives, existing search rules. These guidelines ensure that the data adheres to industry standards, organizational policies. Third-party intelligence, leveraging external intelligence source further enriches data. Google Knowledge API and Graph, competitor websites and search results, large language models, EIS, MRO knowledge graphs. This external data helps in providing broader context insights. Then we have user context. Understanding user behavior and context is crucial for relevance. Signals / telemetry, search analytics, clickstream analytics, transactional analytics, performance metrics, KPIs, audience segment profile. This data helps tailoring the information to user needs and preferences. Data integration. The data from various sources is integrated with methods such as feed, API, crawl, direct. Data is merged by key elements like series categories, category and attribute code to ensure coherence with the system. Unified document repository. All integrated data is stored in a unified document repository, ensuring centralized access management. Embeddings and indexing. Generate doc embeddings, creating embeddings for documents to capture semantic meaning. Generate textual embeddings, applying contextual embeddings based on application, audience, and behavioral data. Create graph index, building a graph index for relational data. Create vector index, developing a vector index for efficient retrieval analysis. Then we've got preparation and processing. The data undergoes preparation process, including normalization, classification, tagging to ensure it is ready for analysis and use. Generating LLM, context, and metadata. Finally, the enriched data is used to generate context and metadata for large language models, enhancing the capability to provide accurate and relevant responses. This comprehensive enrichment process ensures that the data is not only accurate and complete, but also highly relevant and useful for various applications, ultimately driving better business outcomes and user satisfaction. Here is sample output data, comparing the original and enriched sample output data, showcasing the transformation process and its benefit. The original data provides basic information and classification, but lacks detailed descriptions and keywords needed for optimal searchability and relevance. The new name and description provides a clear understanding of the product's purpose and applications, while the keywords and categories ensure it can be easily found by the target audience. The enriched data not only improves the clarity and usefulness of product information, but also significantly enhances the findability and relevance of the product's various search content, thereby driving better user engagement and business outcomes. Comprehensive naming and description. New names, descriptions, and normalized attribute values are generated by leveraging both internal ACME sources and publicly available data. This ensures that the enriched data is comprehensive and relevant. Conformance to standards. The output results conform to ACME's style guide and industry standards, ensuring consistency, reliability across the catalog. Enriching SEO information and metadata, such as reasoning behind naming and categorization, included in all output records. This enhances the product's visibility and searchability, making it easier for potential customers to find and understand the product. So that's it from me. Please feel free to reach out to me on LinkedIn. We would be delighted to work with you on enriching your product descriptions through large language models and modular RAG. And I am based in New York, so if you're also based here, it'd be lovely to meet in person. If not, I'll see you on Zoom. Thank you.